Have you ever stopped and wondered what's really going on inside the AI tools that are basically changing our world? Well, it turns out that this entire AI boom, from the chatbots to the image generators, it isn't powered by a dozen different things. Nope, it's all built on one single revolutionary blueprint. Let's dig in and see what it is.
So that blueprint, it's called the transformer. Think of it as the engine running under the hood of all the tools you probably use every single day. When you're prompting ChatGPT or making an image with Stable Diffusion or using Google's Gemini, you're interacting with an architecture that all comes from this one core idea.
So what is it? What's the secret sauce here? That's what we're going to break down. The one massive idea behind the transformer that completely changed how machines understand language and really reshaped the entire future of artificial intelligence.
To really get why this was such a breakthrough, we first have to understand the problem it was designed to solve.
See, back before 2017, AI had this major bottleneck when it came to understanding language. It was just stuck, processing everything in a slow, one thing after another, and honestly a pretty forgetful way.
The big models back then were called recurrent neural networks, or RNNs. And you can think of an RNN like a person reading a really long book, but only one word at a time. It reads the first word, then the second, then the third, and with every new word it reads, it tries to kind of update its memory of everything that came before.
And that right there is the core of the problem. You know, the technical term is the vanish ingredient problem, but it's easier to just think of it as the model's memory fading. By the time it gets to the end of a long paragraph, all the important details from the beginning are just too fuzzy to remember. And that inability to connect ideas over long distances, it was a huge roadblock for making any real progress.
So let's just put it side by side. The old way, the sequential way, was slow, it was forgetful, and it was really hard to scale up with modern computers. The new way, the transformer, is parallel. It looks at everything at once, which gives it the full context. And that makes it incredibly fast and super scalable. This fundamental shift is what set the stage for everything that was about to happen.
And the solution? Well, it arrived in a moment that has pretty much become legendary in the AI world.
In 2017, 8 researchers at Google published this landmark paper, and the title was kind of perfect, a little nod to the Beatles and a Super Bowl declaration: attention is all you need. This paper introduced the transformer architecture, and it just changed everything.
The paper's big revolutionary idea was a mechanism called self-attention, and it totally flipped the script. Forget reading word by word, self-attention lets the model process every single word in a sentence at the exact same time. And for each of those words, it can look at all the other words to figure out which ones are most important for understanding its meaning in that specific context.
Okay, a great way to wrap your head around this is to think of it like a web search. For every single word, the model creates 3 things: a query, a key, and a value. So the query is the word that's looking for context. That's your search term. The keys are like the titles of all the other words, kind of advertising what they're about. The model compares the query to all the keys to find the best match. And once it finds one, it pulls the value, the actual useful info from that word. By doing this for every word all at once, the model builds this incredibly rich, connected map of the whole sentence.
So that's the powerful core idea. But how does it all fit together? Let's take a quick look at the simplified blueprint.
From a high level, it's basically a 3-stage process. First up, embedding. This is where words get turned into numbers, vectors that capture their meaning. Second, these vectors get passed through a whole stack of transformer blocks. This is where all that self-attention magic happens, refining the meaning layer by layer. And finally, the processed vectors go to an output layer, which turns them into probabilities to guess the most likely next word.
But here's where it gets even cooler. The model doesn't just do that web search once. It uses something called multi-head attention. Imagine having a team of experts, say a dozen of them, all looking at the same sentence at the same time, but each one is focusing on something different. One might be tracking grammar, another is looking at the overall meaning, another might be looking at relationships between words. This gives the model a much richer understanding of what's going on.
Okay, wait a second. You might be wondering, if it looks at all the words at once, how on earth does it know the word order? That's a fantastic question, and it solves this with something called positional encodings. It basically adds a little numerical signal to each word that tells the model its exact position in the sentence, whether it's the first word, the second, the 10th, and so on. Pretty clever, right?
So we have this elegant, incredibly powerful architecture. What was the result?
Well, to put it mildly, it was nothing short of a revolution.
That shift from sequential, one-by-one processing to parallel, all-at-once processing was the absolute game-changer. Being able to do all these calculations at the same time meant these models could be trained on modern computer hardware with unbelievable efficiency. And this didn't just let us build slightly bigger models, it unlocked the ability to build them on a scale that was just unimaginable before.
And you can just see the explosion that followed on this timeline. The paper drops in 2017, boom. By 2018, we have the first GPT and BERT. By 2020, GPT-3 shows up and blows everyone away. And then just 2 years after that, ChatGPT puts this immense power into the hands of hundreds of millions of people. The speed of it all was just breathtaking.
And just look at the scale we're talking about here. The numbers are mind-boggling. The original transformer model had about 65 million parameters. GPT-3, just 3 years later, jumped to 175 billion. Today, the biggest models are cruising past 1 trillion parameters. That kind of exponential growth is a direct result of the transformer scalable parallel design.
And you know what? It didn't stop at text. The transformer has proven to be this kind of universal architecture. By treating pixels in an image as a sequence, or sound waves as a sequence, the same fundamental idea is now driving huge breakthroughs in image generation, computer vision, robotics, even scientific discovery. It's everywhere.
So yeah, the transformer has totally defined this current era of AI. But the story's not over, not by a long shot. Let's look at what's ahead.
Which brings up a good question. After all that, is this architecture the final word in AI? Not quite. Like any technology, it's got its own set of challenges that researchers are working around the clock to solve.
For one, that immense scale comes with an immense computational cost. They also have this weird weakness with really long texts. They tend to remember the beginning and the end way better than the middle. And of course, like a lot of these complex AI systems, they're still kind of a black box, which makes it really hard to understand exactly why they make the decisions they do.
And that all leads us to our final question. The idea of attention completely redefined what was possible in the last decade. So solving these new challenges, efficiency, context, interpretability, that's the grand pursuit of this decade. What that next revolutionary idea will be, nobody knows for sure. But one thing is certain, its impact will be felt everywhere.